All right, you crazy fuckers, welcome back to the deep dive. You know the drill. One of you gets a wild hair up your ass about some crazy-ass topic, sends us a stack of articles, and we dive in head first. Today we're tackling a question that's been bugging the shit out of a lot of you. What the fuck are those goddamn atom smashers? And are they going to spawn a black hole that'll swallow us whole? I mean, particle accelerators sound like something straight out of a goddamn sci-fi flick, right? But trust me, they're real as hell. And the shit they're doing is mind-blowing. So to break down this mindfuck, we've got a real expert in the house. Someone who actually gets this shit. No more bullshit. Tell us what the fuck a particle accelerator is. And keep it simple. Like you're explaining it to your drunk uncle at a family BBQ.
Right. Imagine a giant electric racetrack, but instead of cars, we're whipping around tiny particles like electrons and protons, and these little bastards get jacked up to insane speeds, almost the speed of light, and then we smash them together to see what the hell happens.
So it's like a demolition derby for atoms. That's fucking metal. But wait, I read there are like over 30,000 of these things scattered across the globe. Seriously, who knew there were so many places smashing atoms?
Yeah, it's wild, right? But hold your horses. They're not all these massive underground behemoths like the Large Hadron Collider you hear about. Some are surprisingly small, like the ones used in old school TVs and X-ray machines.
Hold the phone. X-ray machines. So those things at the airport are basically mini atom smashers. That's kind of fucked up, man. They're seeing through my junk and shit.
Well, not exactly. X-ray machines use a very specific type of particle accelerator, but the point is not all particle accelerators are built for these grand universe-probing experiments. There are two main types: electrostatic and electrodynamic. The electrostatic ones use static electricity to juice up the particles. It's simple, but effective.
So it's like rubbing a balloon on your head to make your hair stand up. Except instead of hair, we're talking about subatomic particles.
Kind of. It's all about generating that electric field to get those particles moving. Now, the electrodynamic accelerators, those are the real beasts. They use changing electric fields to really ramp up the energy. Think of it like surfing a wave. But the wave is electromagnetic, and the surfer is a tiny particle getting blasted to near light speed.
Okay, that's pretty rad. So we got these atom smashers zapping particles in hospitals and powering our old TVs. But let's get back to the crazy shit. The universe splitting stuff. You mentioned smashing particles to understand the Big Bang. How the hell does that even work?
It's not about recreating the Big Bang itself, but rather replicating those insane conditions that existed right after the universe popped into existence. Crazy high energy and density. And that's where these massive colliders come in. We're talking miles-long underground tunnels where we smash beams of particles head-on, mimicking the chaos of the early universe.
Holy shit, that's nuts. So they're basically trying to recreate the Big Bang in a lab. What could possibly go wrong? I mean, we've all seen those disaster movies where some experiment goes haywire, and next thing you know, there's a giant monster rampaging through the city. Are we all going to get fucked by a black hole or something?
Well, the black hole thing is a popular concern. Honestly, it's not totally out of the realm of theoretical possibility, but let's not get ahead of ourselves. We've got a lot more to uncover about these atom smashers before we dive into the doomsday scenarios.
Right, all right, I get it. But you got to admit, the idea of scientists accidentally creating a black hole that could swallow the Earth is pretty damn terrifying. And you're saying it's not impossible? Fuck, that's some nightmare fuel right there.
Okay, let's take a step back and break this down. First, we need to understand how these colliders actually work. Imagine two beams of particles racing towards each other at nearly the speed of light.
Like a cosmic game of chicken. Except instead of cars swerving, they smash into each other.
Yeah, something like that. And when these particles collide, they release an insane amount of energy, which can create new particles and potentially reveal some crazy secrets about the universe.
Okay, but what about the black holes? Don't those things suck up everything in their path?
All right. I knew we'd get to the black holes eventually. It's true that some physicists have theorized that these high-energy collisions could potentially create microscopic black holes. But here's the thing.
Don't sugarcoat it. Tell us, are we all going to die?
Relax, dude. Even if they did create a black hole, it would be so tiny, like smaller than an atom, that it would evaporate almost instantly. It wouldn't have time to suck up anything, let alone the entire planet. Plus, we're constantly bombarded by cosmic rays, some with way higher energies than anything we can cook up in a lab. And they haven't turned Earth into a cosmic vacuum cleaner yet.
So you're saying even if they made a black hole, it'd be like a fart in the wind?
Well, I wouldn't put it quite like that, but the point is it's not the apocalyptic threat some people make it out to be.
All right, that's somewhat reassuring. But still, these scientists are playing with some seriously powerful forces. What stops these particles from just flying off in all directions like a goddamn fireworks show?
That's where magnets come in.
Right.
Really, really fucking strong magnets.
Magnets.
Yeah.
Seriously, like the ones I used to play with as a kid.
Not exactly. These are electromagnets, and they're thousands of times stronger than the Earth's magnetic field. They keep those particles contained in a tight beam, guiding them around the track and focusing their energy.
So it's like a magnetic rodeo wrangling these tiny little particles and making them do our bidding. That's wild, man.
Exactly. And the stronger the magnets, the more powerful the accelerator can be, and the higher the energy we can achieve in those collisions. But there are limits.
Limits like what? You mean besides creating a planet-eating black hole?
Well, there are practical challenges. One of them is something called synchrotron radiation.
Synchrotron radiation. That sounds like something I'd get from spending too much time in a tanning bed.
It's a bit more complicated than that, but basically when you accelerate charged particles in a circle, they lose energy by emitting this radiation. So as you push for higher and higher energies, you need to compensate for these losses. That's why some accelerators are built in these massive underground tunnels, miles in circumference, to minimize the curvature and therefore the energy loss.
Okay, so bigger is better. But isn't there a point where these things just get too damn big and expensive to build? Like, how much bigger can they get?
That's a major question facing the future of particle physics. Building bigger and bigger accelerators is becoming increasingly challenging and expensive. But there are some exciting new technologies being explored, like plasma wake-field acceleration. That could potentially lead to more compact and efficient accelerators in the future.
Plasma wake-field acceleration? That sounds like some Star Wars shit.
Yeah.
So instead of magnets, they're using like laser beams or some shit.
It's a bit more complicated than that. But basically, yeah. The idea is to use a laser or particle beam to create a wave in a plasma, and then surf that wave to accelerate the particles. Think of it like a surfer catching a wave, but on a subatomic scale.
Damn, that's the next level of shit. So they're basically trying to hack the laws of physics to create even more powerful atom smashers. That's some serious sci-fi shit, man.
It's definitely cutting-edge science.
Yeah.
But it's still in the early stages of development. There are a lot of technical challenges to overcome before it becomes a practical reality.
So what you're saying is we're not going to have a Death Star anytime soon. Some serious knowledge on those. Today we've covered a lot of ground.
Yeah.
From giant underground atom smashers to the theoretical possibility of mini black holes. But before we wrap up this part of the deep dive, I got to ask you one more thing. You know how Joe Rogan is always going on about the simulation hypothesis?
Yeah. The idea that we're all just living in a giant computer simulation.
Exactly. Man, if that's true, these particle physicists are basically messing with the code, right? What do you think about that?
Well, that's a fascinating philosophical question. I can't say for sure whether we're living in a simulation or not, but it's certainly an intriguing thought. If it were true, then particle accelerators might be giving us a glimpse into the underlying structure of that simulation.
Dude, that's mind-blowing. Like we could be uncovering the pixels of reality itself.
It's certainly a possibility, but even if we're not in a simulation, particle physics is still uncovering the fundamental building blocks of the universe. It's a quest to understand the very nature of reality, and that's pretty incredible in its own right.
Welcome back to the deep dive. Before we went to the ads, we were talking about how these particle accelerators use crazy strong magnets to wrangle those tiny particles, right? Well, let's get into the nitty-gritty of how these bad boys actually work.
Hell yeah, let's do it. Magnets have always seemed kind of magical to me. It's like, how the fuck do they even work? They just like pull shit towards them. It's spooky as hell. Well, magnets work because of the interaction of magnetic fields.
Right.
And in a particle accelerator, we use electromagnets, which are basically coils of wire that create a magnetic field when an electric current runs through them.
So it's like electricity making magnetism. It's
Yeah.
all connected, man. The universe is trippy as hell.
Exactly. And by carefully controlling the strength and direction of these electromagnets, we can steer and focus the particle beam with crazy precision. It's like playing a cosmic video game. But instead of a joystick, we're using magnets to guide these little bastards to their doom.
So these magnets are basically like the invisible fences for subatomic particles, keeping them from running wild and causing chaos, except instead of a shock, they get smashed into oblivion. That's metal as fuck.
You could say that. And just like with a real fence, the stronger the magnetic field, the more effectively it can contain the particles. That's why some of these accelerators have magnets that are thousands of times stronger than the Earth's magnetic field.
Holy shit, that's insane. But
Yeah.
wait, I thought you said these particles are moving at nearly the speed of light. How the hell can a magnet even keep up with that? It's like trying to catch a bullet with a pair of tweezers.
That's the beauty of electromagnetism. The magnetic field acts on the particles instantaneously, no matter how fast they're moving. It's like they're connected by an invisible force, and the magnet has the ultimate control.
So it's like a cosmic speed trap. These magnets are like, nope, you're not going anywhere, buddy. You're going to get smashed.
Pretty much. And by adjusting the strength and configuration of these magnets, we can make the particles turn speed up, slow down, and even collide with each other. It's a symphony of destruction, all orchestrated by these powerful magnets.
Okay, so we got these magnets steering the particles around like a racetrack. But how do they actually make them go faster? I mean, we're talking about speeds that would make a fighter jet look like a snail. What kind of juice are they using to get these things up to ludicrous speed?
That's where radio waves come in. Accelerators use something called radio frequency cavities, which are special chambers that create oscillating electric fields.
Radio waves, like the stuff they use for music and shit. So they're blasting these particles with heavy metal to make them go faster.
Same principle, but much higher frequency. And these electric fields are timed perfectly to give the particles a little kick every time they pass through. It's like pushing a swing at just the right moment to make it go higher and higher.
So it's like a cosmic dance. The magnets are guiding the particles, and the radio waves are giving them a little boost every time they go around. Man, the universe is a weird and wonderful place.
Exactly. And with each lap around the accelerator, the particles gain more and more energy, getting closer and closer to the speed of light.
But why go so fast? I mean, what's the point of making these particles move at ludicrous speed? Is it just to see how much we can fuck with the laws of physics?
Well, the faster the particles are moving, the more energy they have. And when they collide, that energy gets converted into new particles. According to Einstein's famous equation,
EMDCPO. That's like the most famous equation ever. What does it even mean? I barely passed high school physics.
it means that energy and mass are interchangeable. So when we smash these particles together at high energy, we can create new particles that were never there before. It's like alchemy. But on a subatomic level, we're basically smashing atoms together to see what kind of crazy shit comes out.
So they're creating matter out of pure energy. That's some seriously godlike shit, man.
It's pretty amazing stuff. And by studying the properties of these new particles, we can learn more about the fundamental building blocks of the universe and the forces that govern them.
So it's like they're playing cosmic Lego, smashing things together and seeing what new stuff they can build.
You could say that, but these Legos are incredibly tiny and behave in ways that defy our everyday intuition. They're governed by the strange laws of quantum mechanics, where things can be in multiple places at once, and particles can act like waves. It's a wild world down there.
Right, let's talk about some of these crazy particles. What kind of weird shit are they finding in these atom smashers? Are we talking about subatomic monsters or something?
We found a whole zoo of particles, with names like quarks, leptons, and even Higgs boson.
Higgs boson. Isn't that the God particle everyone was freaking out about a few years ago? The one that like gives everything mass?
Exactly. The Higgs boson is a special particle that gives other particles their mass. It's like the cosmic glue that holds everything together. Without it, the universe would be a very different place.
So without the Higgs boson, we'd all just be floating around like massless ghosts. That's some spooky shit, man.
Well, not exactly ghosts, but without mass matter, wouldn't be able to form the structures we see around us, like stars, planets, and even ourselves. We'd be a bunch of formless energy drifting aimlessly through the void.
So the Higgs boson is like the MVP of the universe.
You could say that it's a pretty important piece of the puzzle.
Okay, but what about the other particles? What do quarks and leptons do? Are they just hanging out waiting to get smashed?
Well, quarks are the building blocks of protons and neutrons, which make up the nucleus of an atom. And the leptons are a different type of particle that includes things like electrons and neutrinos.
Neutrinos, those are like the ghost particles that can pass right through matter. Like a neutrino could fly right through the Earth and not even notice it was there. That's trippy as hell.
Exactly. Neutrinos are incredibly difficult to detect because they interact so weakly with other matter. But they're everywhere, constantly streaming through us from the sun and other cosmic sources. Billions of them are passing through you right now.
So we're all swimming in a sea of neutrinos. That's mind-blowing. It's like we're all connected on some subatomic level.
It is pretty wild to think about. And studying neutrinos can tell us a lot about the sun supernovae and even the early universe. They're like little messengers from the cosmos, carrying secrets about the most extreme events in the universe.
So these atom smashers aren't just about finding new particles. They're also like cosmic telescopes, giving us a glimpse into the most distant and extreme events in the universe.
Absolutely. Particle physics is a powerful tool for exploring the universe, both at the smallest and largest scales. By smashing atoms, we're unlocking secrets about the very fabric of reality.
All right, expert speaker, you've officially blown my mind. This is some seriously next-level shit. But before we dive even deeper into this cosmic rabbit hole, let's take a quick break. Stay tuned because in part 3 of our deep dive, we're going to explore the limits of particle physics, the search for new physics beyond the standard model, and the ultimate question, what is the universe made of? All right, you beautiful bastards, welcome back to the deep dive. We're knee-deep in the world of particle physics and shit's about to get really weird. Before the break, we were geeking out about all those crazy particles they're finding with these atom smashers. Quarks, neutrinos, the Higgs boson, all that crazy shit. But here's the thing that's really blowing my mind. I read that all this stuff, all the particles and forces we know about, only makes up like 5% of the universe. 5%. What the fuck is going on with the other 95%? Is it all just empty space? Or is there something else out there lurking in the shadows, something we can't see or touch?
You're hitting on one of the biggest mysteries in physics right now, the stuff we can see and interact with. The matter made of atoms is just a tiny fraction of what's actually out there. The rest is this mysterious stuff we call dark matter and dark energy.
Dark matter, dark energy. Sounds like some edgy superhero bullshit. What the hell are these things? And how do we even know they exist if we can't see them? It's like trying to prove that unicorns are real because you found some glitter in your backyard.
We can't see dark matter or dark energy directly, but we can see their effects on the stuff we can see. Think of it like this. You see a curtain billowing in the wind, even though you can't see the wind itself. We know dark matter is out there because it affects the way galaxies rotate. They're spinning way faster than they should based on the amount of visible matter they have. It's like there's this invisible hand holding them together, preventing them from flying apart. And that invisible hand is dark matter.
So dark matter is like the cosmic scaffolding holding galaxies together. That's pretty mind-blowing. But what about dark energy? What's its deal? Is it like the evil twin of dark matter, trying to tear the universe apart?
Dark energy is even weirder. It's causing the expansion of the universe to accelerate. It's like there's this anti-gravity force pushing everything apart, making the universe bigger and bigger.
Hold up, anti-gravity. So instead of pulling things together, it's like blowing the universe up like a balloon. That's some seriously fucked up shit, and we have no idea what it is.
I have some ideas, but nothing concrete. It's one of the biggest mysteries in physics today.
So particle physics is basically like a giant cosmic puzzle. And we're still missing most of the pieces. Talk about a mind fuck.
Right.
I think we understand how the universe works, but then we realize that we're basically clueless.
It is a bit humbling. We've come a long way in understanding the universe. But there's still so much we don't know, and that's what makes it so exciting. There's always something new to discover, something that could completely change our understanding of reality.
All right, so we got this standard model of particle physics that explains all the stuff we know about the particles, the forces, all that jazz. But then we got this dark matter and dark energy shit that's like a giant question mark hanging over everything. Are scientists trying to find new particles that might explain this dark stuff? Is that what they're doing in those giant atom smashers?
Absolutely. There are tons of theories about what dark matter and dark energy might be made of. And scientists are looking for any evidence of new particles that could fit these theories. They're building bigger and better detectors, designing new experiments, and pushing the limits of technology to try and catch a glimpse of this hidden universe.
So they're basically hoping to smash some particles together and be like, aha, dark matter. It's like trying to find a needle in a haystack, except the haystack is the entire goddamn universe and the needle is invisible.
But it's not quite that simple. But the idea is that if we can create enough energy in these collisions, we might be able to produce new particles that interact with dark matter or dark energy. It's a long shot, but it's the best bet we have right now.
So the hunt is on for these new particles. What kind of crazy shit are they looking for? Are we talking about particles that can travel through time or teleport or control people's minds?
There are lots of possibilities. Some theories suggest that dark matter is made up of weakly interacting massive particles or WIMPs. Others propose axions, sterile neutrinos, or even supersymmetric particles.
Supersymmetric particles? That sounds like some comic book shit. Do these particles have superpowers or something? Can they fly? Shoot lasers from their eyes?
Well, not superpowers in the traditional sense, but supersymmetry is a theory that predicts a whole new set of particles that are partners to the ones we already know about. It's like every particle has a secret twin lurking in the shadows. And some physicists believe that these supersymmetric particles could be the key to understanding dark matter.
So it's like a cosmic conspiracy. The universe is hiding all this crazy shit from us,
Hmm.
and we're just trying to peek behind the curtain.
In a way, yes. The universe is full of secrets, and it's up to us to unravel them.
Okay, I gotta ask, are you ever like totally freaked out by how much we don't know about the universe? I mean, it's kind of terrifying to think that most of the universe is made of this invisible stuff that we have no clue about. It's like, what if this dark matter is actually some malevolent force that's going to consume us all? Or what if dark energy is ripping the universe apart and we're all just along for the ride?
Honestly, I find it more exciting than terrifying. The universe is full of mysteries. And it's the quest to solve these mysteries that drives scientific exploration. It's the unknown that keeps us going, that pushes us to ask questions and seek answers.
All right, you crazy fuckers, that's about all the mind-blowing physics we can handle for one day. We've gone from smashing atoms to contemplating the end of the universe. I don't know about you, but my brain is fried. Thanks for breaking it all down for us. You've given us a lot to think about.
It's been my pleasure. Hopefully, I've inspired some of you to go out there and learn more about this amazing universe we live in.
And all you listeners out there, we hope this deep dive has sparked your curiosity about the universe and the incredible science that's trying to unlock its secrets. We've just scratched the surface here, but hopefully it's given you a taste of the mind-bending world of particle physics. Keep those questions coming, and we'll see you on the next deep dive.
Stay curious, stay skeptical, and never stop exploring the world around you. Peace out.